Right. Okay, so we're going to have a look today at mortgages. Okay. So we're going to have a look today at mortgages. Obviously, they're the last thing we kind of have to do. So think of a mortgage, I suppose, like a reverse pension. Okay. With a pension, you put in a certain amount each month, each year, whatever, and at the end of it, you get a big lump sum. Okay. And it accrues every month. Okay. So you put in a fixed amount at a certain rate, and at the end of that, you get a big lump sum. Mortgages are complete reverse. So in a mortgage, you get a big lump sum, and then every month you pay in a fixed amount at a percentage rate, and at the end you don't owe anything. So you're paying it back. So if we think about it very, very carefully, okay, it's the same as the present value one so if you remember our present value from the previous video, the present value was always going to be P over 1 plus R, and that sequence. So it's that same idea. Okay, so if you think about it, the mortgage amount, okay, is always going to be equal to the amount you pay back. Okay, the amount you pay back over 1 plus I plus the next one, the amount you pay back over 1 plus I squared plus the amount you pay back for your last one, 1 plus I to the t, whatever amount it is. Now, you're probably saying to yourself, well, wait a second. When we did the present value of our investment, we started out with the amount, and then the next one was. But remember, with a mortgage, you don't pay till the end of the month. Okay, so when you get your mortgage, not any of you have gotten a mortgage, but when you get your mortgage, let's say you're getting a mortgage for €200,000. Okay, and you're agreeing to pay back 1,000 a month. Okay, so you're agreeing to pay back 1,000 a month. Your first payment isn't due, okay, until the first month is over. So that allows them to accrue the interest on it. Otherwise, you'd be gaining money off them, because if you paid it back, if you had 200,000 on, the 28th of February, and then on the 1st of March, you paid back the first 1,000, there's no interest accrued. So they haven't made any money off you. So they wanted 1 month after you draw down. Now, there's some you can negotiate that with them, but it's usually in month. It's in 4-week calendars, so the first payment won't be due. So they want that when you're always trying to catch up on that interest over that month that you've accrued by paying it back. Okay, so that's the kind of theory behind it. So let's have a look at how it actually works. Well, look, when you can see that done there, well, you can see what that is. Okay, that's just A. You got your R. And we were using our SN formula. Okay, so in this case, A is going to be the amount over 1 plus I. R is going to be 1 over 1 plus I, same as before, and T is just going to be T. Okay, T is equal to T. So let's put it into our formula, because we know this formula already. Okay, so let's do it out properly, because luckily enough, this one's on page 31 of your log tables. But I'm going to show you how, in case you're asked to derive it, just in case. Okay, so start with your mortgage. So let's get our A. It's going to be equal to amount over 1 plus I multiplied by 1 minus R to the N over 1 minus R. Okay, so let's try and turn it in to what we want to turn it in. Park that one for a second. Common denominator here, let's distribute the t. So it'll be 1 to the power of t over 1 plus I to the power of t. So top fraction will have 1 plus I to the power of t as a common denominator. over the bottom fraction, just have 1 plus I as a denominator. So top fraction, if it has 1 plus I, we're going to be left with, let me see here now, 1 plus I to t, we're going to be left with, we're going to be left with, let me see, 1 plus I to the t, we're going to be left with 1 plus t, 1 plus I to the t, and minus 1. And then on the bottom fraction, if I make that come there, she'd have 1 plus I minus 1. So you just have I. So when I turn that now into that, it looks horrible, but that is equal to AMT over 1 plus I. So we'll use our little trick. I taught you this before. That gets multiplied by the top line and these two lines together. So I'll have 1 plus I multiplied by 1 plus I to the t minus 1 over I times 1 plus I to the t. Now I can see something happening here. Try and get a different color. Oh, I don't think I have a different color. I don't think I have one. I don't. So I don't have a different color, but that counts as, this is a multiplication operation. So that counts as with that. So that leaves us with AMT by 1 plus I to the t minus 1 over I times 1 plus I to the t. I to the t. So see it there? That's what that leaves us. So that's what the mortgage is equal to. The amount multiplied by 1 plus I to the t minus 1 over 1 I times 1 plus I to the t. Okay? Now, you can rearrange this because on page 31 of the log tables, you can actually get the amount on its own. So the amount will be equal to, well, all I'm doing is dividing that across. You know, all I'm doing is dividing that across. So the amount that you're going to repay each month is just going to be equal to the mortgage multiplied by, reverse this, turn upside down, basically. I times 1 plus I to the t over 1 plus I to the t minus 1. So you can reverse that. So these two are reversible, as you can see. So in this form, the mortgage is equal to your repayment amount by this, and then your repayment amount is equal to your mortgage multiplied by that. So we're going to give a few of these a go, see how we get on with them, and hopefully, you know, some of this will make sense to you. So we'll start with Alice. So give Alice a read there. So poor old Alice has got a mortgage. She's going to take out a 20 grand mortgage, as you do. And what's she going to do? All right, she's going to take a 20-year mortgage, 8%. Jesus, 8%. The interest rate over the lifetime of the mortgage is 8% a year. She can afford this per month. What's the largest mortgage she can afford to get? So this is her maximum. This is her maximum amount that she can afford. So that's going to determine what mortgage she can get. And we need to give our answers. Let's put in all the details. So first of all, it's per month. So let's get to 20 years in months. So 20 years times, what is it, 12? 20 years times 12 is 240 months. Okay, so T is equal to 240. Right, so we've got 8% per annum. Okay, so we're going to have to work this out because 8% per annum, so the rate is 1.08. The problem with it is that that's per annum. We want it per month, so we're going to do our little trick. So remember, what's our little trick again? It's 1 plus I to the power of 12. No, it's not 12, is it? Yeah, it is 12. is equal to 1.08. So we get the 12th root of 1.08 and subtract 1. So I is equal to the 12th root of 1.08 subtract 1. So 12th root 1.08, sorry, subtract 1. Okay, so whatever that is. I don't really know what that is, but it's 6.434 by 10 to the minus 3. 6.434 by 10 to the power of minus 3. It's 0.643% per month, basically. That's the interest you have to pay back on this mortgage. And I'm assuming it's a fixed rate mortgage, not a tracker or anything like that, because we're not going into that. So we have all the information we need. So we just need to figure out our payment. So remember our payment, or did I just write it down there? So the amount is just going to be the, we're going to look for the mortgage bit. So you can either, this is the one you're going to get in the log tables. So you can either slot in everything you have and divide that into that, or if you can rearrange it, it's just that. So I'm just going to use the one that's in the log tables and we'll just figure it out. Okay, so we have the amount, which is 850, isn't it? That's the maximum amount. 850 is going to be equal to the mortgage amount multiplied by, here we go, I, which is 6.434 by 10 to the minus 3, bracket multiplied by, and then what is it? 1 plus I to the power of n. So that's, whatever that is, 1 plus 6.434 by 10 to the minus 3 to the power of n, which in this case 240, mother of God, over 1 plus I to the power of n minus 1, which is 1 plus 6.434 by 10 to the minus 3 to the power of 240 minus 1. So I'm just going to divide that number by that crazy sum. Okay, sorry, that's inside the brackets there. That 240 is on that bracket there. So 850 divided by bracket fraction. My God. 6. Oh, I have to store an answer, I think. Bracket 1 plus answer to the power 240. This is going to be a complete disaster, but I'll try it anyway. Over bracket 1 plus answer to the power of 240 minus 1. If this works, I'm just like, I mean, so I'm just using the answer. I'm hoping that's the answer in it. Okay. So this is what we're looking for is we're looking for the mortgage. So we're looking for a number bigger than 850 and we're not looking for an error. Okay. So to the nearest 100, that's 103,800, I want to say. So the mortgage she can get is 103,800 euro. So there you go. Okay, so remember, that is in the log tables as it stands, and you can manipulate it around as you need to do it. Okay, so, you know, hopefully you'll be able to, we'll try another one. No point in stopping there, as they say. We'll try another one. Okay, so let's have a look at Malcolm. Poor old Malcolm. Okay, so give it a read there. So Malcolm needs 400 quid per month for 3 years while he studies at college. So he's going to, what amount of money need to invest? So in other words, we're looking at mortgage. What money do they need to put in for our parents? Okay, so in order for this to kind of divvy out, now let's try and think of this one. So he needs 400 a month. So let's try and put all our numbers in together. So we have 6.6% per annum. That's 0.066. So we have, we have an I is equal to 0.066. It's per month. Is it compounded per annum? Monthly. Okay. So we have T is, what is it, 3 years, so that's 36 months, and he needs to be paid, we need to pay him 400 a month. Lucky fella. Right, so first of all, we need to get this back down to the monthly. Okay, so listen, we already know the algorithm. It's just going to be the 12th root of 1 plus this, and then take away 1. So listen, we'll get the new I. Okay, the monthly I is going to be 1 plus 0.066, and we'll get the 12th root. 12th root of the answer minus 1. Right, so we've got 5.34 by 10 to the minus 3. That's the monthly interest. Okay, so we've got the monthly interest, and we want to know how much they're going to need to throw in here for this to happen. So, boom. So 400 is going to be equal to the amount they have to put in, same as a mortgage, multiplied by 5.34 by 10 to the minus 3. So that's your interest, multiplied by 1 plus 5.34 by 10 to the minus 3 to the power of 36, close the bracket, over 1 plus 5.34 by 10 to the power minus 3 by 36 negative 1. And I'm going to do the same thing again. I'm just going to divide 400 by that number. 400 divided by, in a bracket, fraction, the answer, bracket 1 plus the answer to the power of 36, over bracket 1 plus the answer, close bracket, to the power 36, subtract 1, close bracket. They need to put in over 13 grand. So his parents need to put in 13,068 euro and 77 cent in order to fund his lifestyle. Yeah. Interesting. So that's basically what he's borrowing off his parents. It's phrased a bit differently because it's saying the word, how much would to invest. But the reality is, think about Malcolm. From his point of view, his parents are loaning this money. So how much did they loan them, at 6% per annum? That's really what it is. Okay. So that's how those mortgages work. They're pretty cool. Well, not should be able to pay it back. I suppose they're cool for the person who's